In time domain specifications, one of the parameters is steady state error. Today, let us discuss about steady state error. 1 upon 1 plus k is the steady state error. Suppose I am asking, what is the steady state error for Type-0 system? An interview question. What is the steady state error for a Type-0 system? Then immediately you should ask, what is the gain of the system? Static gain of the system. Static gain of the system is k. Therefore, steady state error is 1 upon 1 plus k. 1 upon 1 plus k. So, the steady state error is 1 upon 1 plus k. What is the velocity error? Velocity error. Velocity error means s multiplied by 1 upon s square. Velocity error means r of s equal to 1 upon s square. 1 upon s square. Instead of r of s, if you substitute 1 upon s square, you will get 1 by s here. That's why 1 upon limit s tends to 0, s multiplied by g of s. Limit s multiplied by s g of s. If you let g of s limit s tends to 0, g of s equal to what? K you will get. S tends to 0, g of s if you put for a Type-0 system, you will get k. Therefore, this is equal to k multiplied by s. If you let s tends to 0, you will get 0. 1 upon 0 you will get. Therefore, steady state error is infinity. Steady state error is infinity. Acceleration input. Acceleration input means r of s equal to 1 upon s cube. A Type-0 system, if you take, what you will get is limit s tends to 0. This becomes s square. So what you will get is 1 upon s square plus s square g of s. Type-0 system, that is equal to limit s tends to 0, 1 upon 0 plus this s square becomes 0. Therefore, s square g of s, that is equal to, if you let s tends to 0, you will get 1 by 0. That is equal to infinity, because g of s equal to k. If you let s tends to 0 of g of s, it becomes k. Already we have seen. So s square multiplied by k, that is 0. 1 by 0. That is equal to infinity. Again, steady state error is infinity. Steady state error is infinity. So for a Type-0 system, position error is 1 upon 1 plus k. For a Type-0 system, position error is 1 upon 1 plus k. Velocity error is 1 by 0, that is infinity. Acceleration error is infinity. That's all. For Type-0 system, what is position error constant? Morning we have seen. Limit s tends to 0. Position error constant is kp. Position error constant is kp. Kp equal to what? Limit s tends to 0. G of s equal to k. Kp equal to k. What is velocity error constant? Kv equal to limit s tends to 0. S g of s. You will get 0. What is Ka? Limit s tends to 0. S square g of s. That is also equal to 0. Therefore, if the velocity error constant of a Type-0 system is 0. Acceleration error constant of a Type-0 system is 0. Position error constant of a Type-0 system is k. What is position error? 1 upon 1 plus k. What is velocity error? Infinity, because 1 by 0. That's why infinity. Acceleration error is again 1 by 0. That's why infinity. So if you know the nature of system, Type-1, Type-2, Type-3, we can immediately say the steady state error. For Type-1 system, let us see. For Type-1 system, how it looks like? G of s equal to k upon S multiplied by S plus 1, S plus P1, S plus P2. What is the order of the system? What is the order of the system? 3, third order system. What is the type number of the system? 1. Type number is 1. So let us find the position error constant. Position error constant Kp equal to what? Kp equal to limit S tends to 0 G of S, that is equal to limit S tends to 0 K upon S multiplied by S plus P1 multiplied by S plus P2, that is equal to limit, that is equal to K by 0. K by 0, that is equal to infinity. Position error constant of a type 1 system is infinity. What is velocity error constant? Kv equal to what? Limit S tends to 0. Kv equal to what? Velocity error constant. Sg of S, that is equal to Sk upon S multiplied by S plus P1, S plus P2. We have to write in time constant form. So let us write K dash. So we can write in time constant form. And if you S getting cancelled, limit S tends to 0. If you put, you will get K only. You will get K only. K dash becomes K in time constant form. Time constant form, you will get K only. I wrote in pole 0 form, that's why K dash upon, I'll write and I will explain. K dash upon P1, P2, that is equal to K. That is equal to K. So velocity error constant is K. What is the acceleration error constant? Limit S tends to 0, S square G of S, that is equal to S. Velocity error constant is S multiplied by velocity is S square G of S. Limit S tends to 0, that is equal to S square K upon S, S plus P1 multiplied by S plus P2. Here, one S is getting cancelled. Therefore, you are getting 0. Acceleration error constant is 0. Therefore, what is the error for this? Steady state error for position step input. Position error means step input. What is steady state error? 1 upon infinity. 1 plus infinity equal to 0. Therefore, steady state error for step input is 0. What is the steady state error for velocity input? Velocity input means R of S equal to 1 by S square. Position error means R of S equal to 1 upon S. Steady state error equal to 1 by Kv, that is equal to 1 upon K, 1 by K. Steady state error is 1 by K. What if it is velocity input, acceleration input means R of S equal to 1 upon S cube. E steady state equal to 1 by Ka, that is equal to 1 by 0, again infinity. Infinity. It is moving down. Moving down. Here, type 0 system, what is the first answer? 1 upon 1 plus K. Next answer, for velocity input, infinity. But acceleration input, again infinity. If a type 1 system, first is 0. Second is 1 by K. Third is infinity. Now infinity is reduced in one case. If it is type 2 system, type 2 system, type 2 system. If you take type 2 system, how it looks like? G of S equal to K upon S square 3S plus 1 and 2S plus 1. It is example for type 2 system. Kp equal to limit S tends to 0, G of S, that is equal to limit S tends to 0, K upon 3S plus 1 multiplied by 2S plus 1. It is type 2 0, that's why S square. That is equal to, if you substitute S equal to 0, you will get K upon 0, that's why infinity. You will get infinity. KV equal to what? KV equal to limit S tends to 0, S G of S. That is equal to limit S tends to 0, S K upon S square 3S plus 1 multiplied by 2S plus 1. So the square getting cancelled. However, as S tends to 0, this also becomes infinity. So what you are getting? What is Ka? Ka you will get value. Ka equal to limit S tends to 0, S square G of S. That is equal to S square K upon S square 3S plus 1 and 2S plus 1. If you limit S tends to 0, you will get K. You will get K. Therefore, steady state error for position input is steady state error for position input is equal to what you are getting? Infinity you are getting. Therefore, 1 by 1 plus infinity equal to 0. For velocity input, steady state error equal to 1 upon kV. 1 upon kV. That's why 1 upon infinity, that is equal to 0. If you give acceleration input, steady state error equal to 1 upon Ka. That is equal to 1 by infinity, 1 by K. 1 by K. Now you can notice that as type number increases, in the first case, type 0 system, what error you got? What error for type 0 system? What is the error you got? 1 by 1 plus K for position error. For velocity error, you got infinity. For acceleration error, you got infinity. The second case, you are getting 0. That is, if it is type 1, 0, 0. Type 1 system, velocity input means 1 by K. Type 1 system, acceleration input means infinity. If like that, if it is a type 2 system, the error is 0, 0, 1 by K. That 1 by K is moving down. That's what in this table. If it is position input, that is unit step input. Velocity input, that is ramp input. Acceleration input, that is parabolic input. Position error is 1 by 1 plus Kp. If you substitute 1 by 1 plus Kp, what you will get is 1 by 1 plus K for type 0 system. For velocity error, what you will get? Infinity you will get. For acceleration error, 1 by 1 by Ka suffix A, you will get infinity. The steady state error is for type 0 system, for position input only you are getting 1 by 1 plus K. For other two cases, you are getting infinity. If it is a type 1 system, for position error, you are getting 0 error. For velocity input, you are getting 1 upon 1 by kV, 1 upon kV error. For acceleration input, again, you are getting infinity. It means here it is moving down. The constant term is moving down. Here it is filled with 0. If it is type 2 system, for position error, you are getting 0 error. For velocity error, you are getting 0 error. For acceleration input, you are getting 1 by Ka. So this you have to remember. You have to memorize. No other code. Position input means what? 1 by S. Input is 1 by S. Velocity error means what is the input? 1 by S square. Acceleration input means what is 1 by S cube. For position input, error constants, if you write, it is not in the table, error constants. Error constants. For this, what you will get? For position input, you will get K. For velocity error, you will get 0. For acceleration input, you will get 0. For type 0 system, for type 1 system, what you will get? You will get infinity K 0. For type 2 system, infinity K. Infinity K. That's why If you substitute that k, you will get 1 by 1 plus k. If you substitute that infinity, you will get 1 by 1 plus infinity, that's why 0. If you substitute this infinity, you will get 1 by 1 plus infinity, 0. So this is stable for error constants also. Error constant for type 0 system, type 1 system, type 2 system. Here, what is steady state error for type 0 system? 1 by, for velocity input, 1 by 0. 1 by 0, that's why infinity. Here k, that is equal to 1 by k. Here 1 by infinity, that's why 0. Here what you will get? 1 by 0, that's why infinity. Here 1 by 0, that's why infinity. Here that is equal to 1 by k. Therefore, this 1 by k is moving downward as type number increases. As type number increases, we can give worst input. We can give worst input because what is the first input? Unit step input. Second case is the input is go on increases. For that you are getting steady state error 0 in this case. For type 2 system, for ramp input you are getting steady state error 0. It means a type 2 system will follow the input. Type 2 system will follow the input. In the third case, further worst case, it goes to infinity at infinity only. But if it is parabolic input, now itself it goes to infinity. This is worst input, bad input, good input. This is good. This is bad. This is worst. For worst case, for bad input also it gives steady state error 0 if it is type 2 system. For type 2 system, the worst input is given. The worst input is given. For that it gives steady state error, not infinity. So type 2 system manages parabolic input. Type 2 system manages parabolic input. So that's why type number is important. Type number is important.